Hello everyone. In this video, I'm going to deal with stereochemistry of carbohydrates. We already know that what stereochemistry is. Stereochemistry is nothing but it is a branch of science that deal with the spatial arrangement of atoms. In the 3D arrangement, that means 3D arrangement, it is the determinations of certain molecules or atoms in the form of 3D arrangement is known as stereochemistry. So far, we have learned about what carbohydrates are. Carbohydrates classified into three types. Mainly, carbohydrates are classified into monosaccharides, disaccharides, oligosaccharides, polysaccharides, and so on. Carbohydrates are, we have studied about carbohydrates. It is composed of three main class: monosaccharides, oligosaccharides, polysaccharides, etc. In these polysaccharides, we include disaccharides, trisaccharide, etc. These are the all basic terms we have already learned about. So, for time being, we are going to study about this monosaccharide characteristics. One of the important characteristics monosaccharide is what? Stereochemistry. They show stereochemistry. So, let's learn about the stereochemistry of these monosaccharides. So, uh, before going to the in-depth stereochemistry, let's know about some key terms related with stereochemistry of stereochemistry, some related terms associated with stereochemistry. So far, let's take an example: enantiomer. Enantiomer is one of the important term that is very important to the study of stereochemistry of monosaccharides. Enantiomers, diastereomers, 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 epimers, and anomers. These are the four major terms that are much related with the stereochemistry of monosaccharides. So far, enantiomer means what? Enantiomer means there should be two molecules. There should be two molecules. The two molecules should be mirror images of one another and they cannot be superimposed. That means enantiomer means mirror image. It should be mirror image of one another. Mirror image and cannot be superimposed. Along with example, I will discuss later on. For time being, let's understand what enantiomer actually defined is. Enantiomer is actually defined as what? It should be the mirror image of one another and they cannot be superimposed. So, this is a term related with enantiomers. Then what is diastereomers means? Diastereomers means what? They should not be the mirror image of one another. Should not be the mirror image of one another and can't be superimposed. These diastereomers, there will be two molecules. These two molecules may have similar formula, but they are not mirror image of one another and they cannot be superimposed. So they are known as diastereomers. Along with example, I will deal. And epimers means what? Epimers means there should be two sets of molecules. In these two sets of molecules, they should differ only in certain one chiral center. Say for example, here is one molecule. These molecules contain here, let's suppose it contains hydrogen, 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 hydrogen. This contain OH, OH. This is just an example. Is OH. Let's consider this carbon. This carbon here, let's suppose CH2O is here. This carbon contains CH2OH. This is also ice, this OH. So this carbon is considered as chiral. Chiral because it is surrounded by four different atoms, and in this carbon, this whole group is attached. This is one chiral center. Let's consider about this. This also contain 1, 2, and this whole as a 3, and this whole as a 4. This is also one chiral center. If in case of this epimers, in this type of molecules, there should be another shade also similar, like another molecules also here. If both the molecules are similar in all the chiral center except they differ in one chiral center, they are known as epimers. Along with example I will consider. Let's understand this term. Then anomers means what? Anomers means also they should differ only in carbon number 1. For anomer, they should differ, others should be similar, they should only differ in carbon number 1 for what? Aldehyde, and carbon number 2 for ketones. So let's move to the example so that we can clear about this. So let's take an example for enantiomers. Enantiomers examples, what we have mentioned that enantiomers should be mirror image of one another and they cannot be superimposed. So let's take an example, D-glucose. D-glucose structures, this is very simple structure. D-glucose, it should contain six, 1, 2, it should contain 6 carbon. So this is structures of D-glucose, 1, 2, 3, 4, 5 and 6. It should be CH2OH. Here it should be H, it should be OH, it should be OH, it should be ice, it should be H, it should be OH, it should be H, and it should be OH. What is this? This is the structures of D-glucose. D-glucose, because in this 5th carbon we have already know that what is meant by D-glucose. D-glucose because in this 5th carbon OH is present in which side? OH is present in the right side. So this is the structures of D-glucose. So to find the enantiomorphism of this structure D-glucose, we have to check whether it forms a mirror image. Another structure mirror image should be, this side should be in this side, in say 1, 2, 3, 4, 5, 6. It should be O. In the mirror image, this side should be changes to this side. So here it should be what? Sorry. It should be H. In the mirror image, it should be H and it should be O. It should be what? OH should be this side, H should be this side. Here H should be here, and here OH, here OH, and here H, here what? Here OH and here H, and it should be CH2OH. So let's check. This OH contained in which side? 5th carbon OH is in the OH is in which side? Left side. So it should be what? L-glucose. This L-glucose is mirror image of one another. L-glucose and D-glucose are what? L-glucose and D-glucose are mirror image of one another, because this side is converted into this side. They can form mirror image, but let's say they can superimpose or what? Superimpose means it can be overlap upon this. Say if we bring up this structure, if we bring up this structure and we put upon this structure, what will happen? It will superimpose or what? No, it cannot be superimposed, because if we bring up this, here OH, this OH will fall upon this ice. That means they are not similar, so they cannot be superimposed. Superimposed means one can suppress over others. Say for example, let's take this notebook. This notebook size, another notebook, this another notebook, this can be superimposed upon this. That means it can be overlap upon this, is known as superimposable. And here is H and here is OH, and these are not similar. If we put upon this, it cannot be superimposed. So this head is known as what? Enantiomers. So we are clear about this in term enantiomer, and let's come to the examples of diastereomers. Diastereomers. Diastereomers, we already know that they should have similar formula. Chemical formula should be similar, but they cannot be what? They cannot form mirror image and they cannot superimpose. So diastereomers means what? Non-superimposable mirror image. They can't form what? They can't form mirror image. Negative term is involved here. Mirror image, and also in the same time they cannot be superimposable. So let's take example. Take an example. We take this the glucose again. 1, 2, 3, 4, 5, and 6. Here it should be O. Here it should be H. You have to be very familiar about this D-glucose because we are using this D-glucose very frequently in this carbohydrate chapter. So here it should be H. Here should be OH. Here should be OH. H, H, OH, H, and OH. This is structures of what? This is the structures of D-glucose, D-glucose and D-galactose. Let's draw the structures of D-galactose here. D-galactose means O, H, here H, OH, OH, H, OH, H, H, OH, CH2OH. This is the structures of D-galactose. Let's check, is the D-glucose structures mirror image of this D-galactose? No. This is not the mirror image of this one. If it is mirror image, it should be OH should be which side? OH should be in this side and H should be in this side. But this is not the mirror image of one another and they can't be superimposed. There is no relation among these except the formulas are similar. It contains C6H12O6. It also contains C6H12O6. Let's count this. 1, 2, 3, 4, 5, 6. C6H12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. C6H12 and O6. O6 means 1, 2, 3, 4, 5, and 6. They contain similar formula, but they are not mirror image of one another and they can't be superimposed. So this is known as what? This is known as diastereomers.